Hello everyone, this is Prabhashri, Assistant Professor, Department of Mathematics, SNS College of Technology. So today we are going to see about a case study video. Let's my students will connect with this.
Imagine trying to design a bridge, predict a hurricane, or program a video game without understanding how forces, wind, or movement change in three-dimensional space. It would be impossible. This is where vector calculus comes in. It is the mathematical language of direction and change. Vector calculus allows us to analyze vector fields, which describes quantity with both magnitude and directions, such as fluid velocity or electromagnetic forces. Its applications are vast. In engineering, it is essential for calculating stress or strain on structures, ensuring buildings and bridges don't collapse. In physics, it is the backbone of Maxwell's equation, allowing us to understand electric and magnetic fields. It is also crucial for modern fluid dynamics, such as air flowing over airplane wings or ocean currents. In technology, it is used in GPS navigation to determine the shortest routes and in computer graphics to render 3D, realistic virtual worlds. By using tools like gradients, divergence, and curl, we can move from complex physical behavior to precise engineering solutions. In short, vector calculus isn't just theory, it is the invisible force driving modern technology and our understanding of physical world. Thank you.
Vector calculus is used to study vector fields which represent quantities that have both magnitude and direction, like velocity, force, and electric field. One of the major applications is fluid dynamics. Engineering uses divergence to study how fluids flow through pipes and aircraft wings. Another important application is in electromagnetism. In physics, Maxwell's equation use concepts like gradient, divergence, and curl to describe electric magnetic fields. Vector calculus is not only used for these purposes but also used for weather forecasting to predict storms and cyclones. In robotics and engineering, it helps to calculate motion, acceleration, and the paths. Therefore, vector calculus plays a crucial role in science, engineering, and real-world problem solving. Thank you.
Vector calculus is used to study quantities that have both magnitude and direction, like velocity, force, and electric field. It is mainly used in physics and engineering. In physics, vector calculus helps to describe motion of objects, fluid flow, and electromagnetic field. For example, gradient shows the direction of maximum change, divergence tells how much a field separates out, and curl shows rotation of a field. In engineering, it is used in designing electric circuit, mechanical system, and fluid systems. It is also important in computer graphics, robotics, and weather forecasting to model real-world problems. So, vector calculus helps us understand and solve problems involving motion, force, and fields in real life. Thank you.
Vector calculus is the branch of mathematics. It is used to quantify the both sides and collections, directions like the velocity, forces, and the wind. It is useful to real life and engineering. One important application is physics. Vector calculus helps us to understand motion, gravity, electricity, and magnetic fields. For example, it can explain how plants move and how electricity flows. It also used in engineering. Civil engineering used to study water flow in the river and dams. Machine engineering used to design machines and vehicles by studying the force of moments. Thank you.
Vector calculus is an important part of mathematics that extends calculus to function involving vectors. It helps us study multivariable function and understand how quantities change in space. In mathematics, we use concepts like gradient to find rate and direction of maximum change, divergence to measure how a vector field spreads out, and a curl to study rotation. It also includes line integral and surface integrals, which are used to calculate area, volume, and flow. Vector calculus connects algebra, geometry, and calculus, and it's formed the foundation for advanced mathematical topics and real-world problem solving. Thank you.
So my students insist some applications oriented about vector calculus. Here is some more. So vector calculus plays a vital role in understanding and modeling real world phenomena. So involving changes in multiple dimensions, it is widely applied in physics and engineering to analyze electromagnetic forces like flow, heat, transfer, and gravitational forces. So concept like gradient, divergence, and curl help them to describe how quantities varies in space and time. For example, Maxwell's equations is in electromagnetism is particularly fundamental based on vector calculus. So engineering, it is used to design aerodynamical structures and optimization fluid dynamical also. So overall, vector calculus provides a mathematical framework to study and solve complex multidimensional problems efficiently. Thank you.